And welcome students to our next lesson on polymorphism. Today, let's go ahead and discuss the final modifier. So getting started, we can mark a method to indicate that it cannot be overwritten with a new definition in a derived class. To do this, we simply just add the final modifier to the method heading such as in the final example. So I have public final void some method. Right, if I didn't have final in there, obviously you can overwrite it. With final in there, it pretty much makes it unchangeable. Now, when we talk about final, let's start off by discussing that an entire class actually can be declared final. In which case, if it's a final, you cannot use it as a base class to derive any other classes from it. The syntax for declaring a class to be final is illustrated as follows. Public final class some class. That's all you have to do. So if you want to make your class non-changeable, you just add the word final to it. Now, if a method is marked as final, it means the compiler can use early binding with that particular method, which enables the compiler to be more efficient. That is one advantage of early binding in comparison to late binding, which we discussed in the previous lesson, in that because it's early binding, it can preload a lot of stuff in the CPU, can have it all going. So the computational speed is a lot faster. So if you're looking at efficient algorithms, early binding can actually be advantageous compared to late binding. However, one thing to note is that the add efficiently is normally not that great. All right, so it would be very, very small, the amount that you would get. And pretty much the suggestion is that you don't want to use the final modifier solely for the reasons of efficiency. Usually there's other reasons you want to use final, besides just like, hey, anyway, to make the program more efficient, let me just add final to stuff. Well, there's other ways to do things. Also, it can sometimes aid security to mark certain methods as final. So that would be the primary reason why you want it to be final. You don't want people modifying anything inside the class, so you can mark it as final. We can also view the final modifier as a way of turning off late binding for a method or an entire class. Of course, it does more than just turning off late binding. It turns off the ability to redefine the method then in any descendant classes. So people can't, make a derived class, or if the class is not marked as final, if the method is, then they can't redefine that method for the derived class. So there's no way you can change it. Now, the final modifier, if you add the modifier final to the definition method, it indicates that the method may not be redefined in a derived class. If you add the modifier final to the definition of a class, it indicates the class may not be used as base class to derive other classes. All right, so let's look at an example here called sales records. So it's going to be a couple classes that we're going to look at here. And in these examples, we're going to see some stuff with late binding, but we're also going to see some stuff with final. So suppose you're designing a record-keeping program for an automobile's parts store. You want to make the program versatile, but you're not sure if you can account for all possible situations. For example, you might want to keep track of sales, but you can't anticipate all types of sales. Now, obviously, at first, there'll only be regular sales to retail customers go to the store and buy one particular part. However, later you may want to add sales with discounts or mail order sales with a shipping charge. Now, all of these sales will be for an item with a basic price and ultimately will produce some bill. For a simple sale, the bill is just the basic price. But if you add discounts later on, then some kinds of bills will also depend upon the size of the discount. Now, your program, obviously in this case, needs to compute daily gross sales, which should intuitively just be the sum of all the individual sales bills. You may also want to calculate the largest and smallest sales of the day, or the average sale of the day. Just, some of those like data analytical pieces, like, hey, what was the largest thing that you sold? Oh, we sold this thing that was $2,000 versus, hey, I sold a thing that was like 2 cents. In the average sale, you might see, well, where are we averaging out for the course of the day? Now, obviously, all these can be calculated from the individual bills themselves, but many of the methods for computing the bills will not be added until later when you decide what type of sales you'll be dealing with. Whether discount, mail-in, markup, whatever. Now, because Java uses late binding, you can write a program to total all bills, even though you will not determine the code for some of the bills until later. So in this example, for simplicity's sake, we just assume that each sale is just for one item, although we could, but will not, account for sales of multiple items. So when we look at the example, we're just doing one item, we're just selling it at a time. Now the class materials shows the class sale. So let me just jump over to Eclipse here, and here's sale. All right, and in here you can see we have some instance variable here. I have a private string name, private double price, and here's my constructor right here. All right, it starts off with no name and the price set to 0. And later on, we can go ahead and set all that stuff. You can see in here, it checks to see if the original object is null, otherwise it exits. Otherwise, it's going to set that name to the object name and the object price. And you can also see we have an announcement that says this is a sale class. We have a get price method, which just returns price. We also have a new price here, in which we can set the new price. Of course, it throws an error if we have a negative price added in. We have a get name method to get the name. We also have a set name method. Right, and you'll notice that name cannot be null, nor can it just be an empty, effectively like an empty string. So you have to give it some kind of value. Additionally, you'll also see we have our toString method. We have a bill, which simply, again, just returns the price. And we have an equals deals, sale, other sale. So this just checks to see if other sale is null. Otherwise, it's going to compare the two. We have a less than boolean, which in this case, it's going to check to see if the other sale is null. Otherwise, it exits. Otherwise, what it's going to do, it's going to compare your bill with the other bill. And then, of course, you have down here your equals here. So it's just checking to see if they're equals. Here, it checks to see if it's null. Here, we're using get class. If you recall, we've used that before. And it's going to check to see if these two objects are not equal. Right, otherwise, it returns false. Otherwise, our only other option would be to say that sale of the sales equals to sale of other object, and then we return those. Okay. So now that we've looked at that, let's dive back into the materials here. All types of sales are going to be derived classes of the class sale. The class sale corresponds to a simple sales of a single item with no added discounts and no added charges. Now you'll see that we had the methods less than. And both of those methods that you're going to see have invocations of the method bill. We can therefore later define derived classes of the class sale and their versions of the method bill, as well as the definitions of the methods less than and equals deals, which we gave in the class sale. These we're going to use the version of the method bill that corresponds to the object of the derived class. Okay, so that derived class is discount sale. So if I pop back over here, here's discount sale. And you can see we have that is a derived class because it extends sale. We have our instance available right here with our constructor. And down here, you'll see we have the discount sale right here, constructor. So it's typically going to take a name, a price, and discount. And you see that it uses a super call to get the name and the price, because remember this is a derived class of sale. And then we are also going to set the discount. Right. Similarly, you can see here's our other object, here's our announcement, here's our bill. So this overrides. We have a get discount this time. We have a set discount, and our toString and our equals methods. Right. So notice that this class requires a different definition of its version of the method bill, because again, we overrode that. So if we look here at bill, you can see here it's double fraction equals discount divided by 100, return 1 minus fraction times get price. In comparison, bill here was just return price, so it's significantly different. Now the methods less than and equals deals, which use the method bill, are inherited from the class sale. The base class has them. If we look at the derived class, nowhere in here do we have less than, and nowhere in here do we have get or equal deals, because those methods don't need to be redefined. We just inherited them from sales. But when the methods less than and equal deals are used with an object of the class discount sale, they're going to use a version of the method definition for bill that was given with the class discount sale. So this is a very important thing to note. So even though I'm using an inherited method, the information that's getting plugged into those methods is coming from the derived class. Now this is indeed a kind of fancy trick that Java can pull off, that even though the method is not inherently within like discount sales, it can still use it as if it was part of discount sales. Now let's consider the method call d1.less_d2 for objects d1, d2 of the class discount sale. So this is just a nice little example for us to look at. So obviously the method less than, even for an object of the class discount sale, is given the definition of the base class sale, which we compiled before we ever even thought of the class discount sale, because that's how Java works. It's going to compile sale before discount sale, because discount sale, again, is a derived class. Yet in the method call d1.less_d2, the line that calls the method bill knows enough to use the definition of method bill given for the class discount sale. Again, remember, less than, it's inherited. And the reason why this can all work is because Java uses late binding. If Java uses early binding, it's not going to work. Now the late binding demo gives a sample program that illustrates how the late binding of the method bill and the methods that use bill work in a complete program. So let's just go ahead and quickly take a look at that. Oh, here I have the late binding demo. And in here we have our main method. And you can see here we create a sale item right here at $10. And then we also have a discount sale. All right, so this is a floor mat still. All right, but you'll see it says one item at $11 with a 10% discount. Then down here it says print simple, print discount. This simple is the original item. And then if discount is less than simple, discounted is cheaper. Otherwise, discount is not cheaper. And down here, you can see we have another example with cup holder at $9.90 and $11. So if we just go ahead and run that program, you can see here we have our floor mat price. We have $10. This is a discount 10%. So the total cost is $9.90. So the discounted item is cheaper. In this case, for the second one, for cup holder, we have $9.90, and we have a cup holder price of $11. And in this case, the total cost is $9.90 again. So 11 times 10% is, of course, $9.90, or not times 10%, but times the discount of 10%. So we get the deals are equal, because in this case, this is $9.90, this is $9.90. Now, if it had been the other way around, obviously, we would have got out then that, a different output would have been generated. We'd have to define what it is here with the equals call. Right? Nothing really too drastic there that we haven't seen before. Let's just jump right back in here and say that's the end for today, folks. So hopefully that kind of helps you understand with that example there a little bit with how the final method works, and also with how late binding can work. Oops. And one thing I do want to show in here is that you'll notice that with this example, in here I did not use any final calls. However, if I wanted to make this final, this class, because I don't want anything to be derived from it, all I have to do is add in the word final. Of course, you have to make sure you put it in the right spot. All right. So if I did this, now nothing is going to change if I run this program. All right. However, what does change is if I wanted to make a super discount, well, I can derive, let's say, super discount from sale, but I can't derive it from discount. So I can't inherit any of the methods from that discount sale. Same thing if I had marked one of these methods as final. All right, and that's a wrap, folks. Until next time.